This is Steve Beeson with American Ironworks. We've seen the need in the industry for a type of restraint that can be installed on a hose without breaking connections. This is especially useful in like manufacturing plants where they'll have a hydraulic system in place and they do not want to disconnect the hose to install the restraint. This morning I'm going to give two demonstrations of two different type of restraints that we manufacture. We have the removable style cable choker here, and you'll see that it has the loop on this end, spring, comes around with your cable clamps. And we have a new style, what we're going to call it's the HMPE type fiber. This fiber is 15 times stronger than steel. And again, we're going to do a small demonstration here and just show the ease of install on these. I'm going to hand the camera off to another employee. We're going to start with the HMPE type restraint, and we're going to put it on a type 62 code flange fitting. On these type of failures, on these type of hoses here with your split flange, we've never seen a failure where it blows out the 4 bolts. So we can secure to this area right here. The failures that we've seen with this type of hose is where the hose hydraulics out of the fitting. So with the soft restraint, we simply want to go around it twice. You're going to run through your hole here. Just fit your washers through, and we want to come 2 times the outside diameter. So basically, if your crimp portion of your fitting here is 3 inches, come 3 inches down. Simply bring it up like that. And go around this here twice. Simply put our bolt through there. Tighten that up. You want to pull this in like that, and then we're going to run our rubber snubber up like this and like that, and that's all that it takes there. We've installed our soft check on a 1-inch hose. We're going to be pressuring it up with nitrogen. Should fail around 5,000 to 6,000 psi. And again, we've simply doubled it on this side of the hose, 3 inches back from the end of the fitting here. Came on this side, and you can install this side here behind your quick connect or anything that has a lip on it like this fitting here. All of these systems come tagged in ratings with PSI ratings with fluid and air. We're going to have a mannequin standing over in this area in case the restraint fails, and then after this test here we will also test a 200 PSI whip check, which we're pretty confident it will fail. Let's see how it performs. Yeah, what I want to show you, gentlemen, is look at the deflection, how hard that HMPE fiber pulled in on that hose right there. I mean, it has got it squeezed down. And when you double wrap on your backside around your fitting here, all you have to do is get a double wrap. It'll be behind your quick connect in the field. But looks like our mannequin survived. Now we're going to test a 200 PSI whip check. Back this camera off, yeah. Now we're going to test our 200 PSI whip check and show what the potential damage can be with this type of failure. So, great test. Nitrogen. Now we're going to test a 200 PSI whip check. And you see a lot of these in the field, but a whip check simply loops around the hose like you see right here. I'm going to go ahead and tighten that up. But simply loops over the hose, and it doesn't have the ability to tighten down during a failure. And that's one of the disadvantages to it. We're going to have our mannequin over here to show us what type of results, what type of energy this 1-inch hose pressured up to 5,000 psi in nitrogen can do. So let's give it a shot and see how the whip check performs.